Hello, welcome to another video about Reflexis Flow, our web application platform, and Indigo, the underlying toolset. Today I'd like to tell you a bit more about our database tools. Specifically, I'd like to show you how our data models work. There's another video about the database utilities that don't use data models, so those are more low-level utilities, but we've also created some data modeling tools that help you create databases faster. And one of the reasons for these data modeling tools is that SQLite actually supports a very limited number of data types. So this is something that we talked about earlier. There's like integers, there are reals, the numerics, there are text fields, and the binary fields, the blobs. And well, in real world scenarios, you often end up with, you'd like to have more than that. So, for instance, you'd like to be able to store a date or a timestamp, or an enumeration or have booleans. Well, for SQLite, this is something that SQLite does not support out of the box, but obviously because it's so open to all sorts of values that you put into it, it's something that you can layer on top of the existing facilities. So if you'd like to know more about data types in SQLite, you can go to the SQLite website. It's sqlite.org. Go to documentation, click on, I've just looked it up earlier, but where was it? Programming interfaces, and if you scroll down, here, data types, and here's the list. They call it storage classes and data types: integers, reals, text, and blobs. So no booleans, no specific facilities for timestamps, and fortunately, that's okay, because, like I said, you can layer stuff on top, and Reflexis Flow or Indigo actually help you do that. So I was thinking, and data modeling itself, the term, it in a way, it sounds a bit pretentious. Our data modeling is not very fancy. There are no object relational mappings. There is no mechanism to help you design very complex queries or something like that. But it does help you design your databases. So create the structure of your databases and evolve them. And basically work with them fairly efficiently. So to give you an idea of how things work, I thought it might be best to look at an existing data model. So in the other database tools video, we worked with our releases database. The releases database is the one underneath the portal where you can download our software from. So it holds releases, the various components that belong to releases, and if you log in, you can actually see the descriptions of the highlights of a release, or the notes that we've attached to components with instructions or whatever. And the nice thing about this database is it's actually fairly small, so it's easy to grasp. But there is a data model, and I thought it would be good to walk you through it and talk a bit about it, to give you an idea of how you can create your own model definitions. So another thing I should mention is that I won't go into the data modeler flow. The flow itself, so the data modeler flow, pretty much explains itself, I hope. If not, then then we have a problem. In this video, I'd like to show you that there's another way to work with data models, and it's entirely compatible with how the data modeler flow allows you to create your databases. So that's good. So let's start. Here's the data model of the releases database. I opened it earlier, and if you look at it, you'll notice that there are several sections. First of all, it's fairly small, so this is the entire data model, and there are, if I scroll through it, you notice that there are various sections. There are sections for so-called V-types, and there are sections for enums. So there's a handful of enums and a handful of V-types, and if we go through the V-types, you can see V-types correspond to tables, and I think in the data modeler we call them classes. We could have typed class here as well. It's the same thing. The V in V-type actually stands for virtual type, because it was part of a much larger system way back when we designed it, and the system's still there. So it's part of a VFS, a virtual file system. So there are V-types, V-files, V-folders, V-categories. V-category is actually the other name of enum. These days we usually say enum. Enum is short for enumeration, or a list of options. In any case, in this data model, in data models, you define your V-types, your tables, or your enumerations. And I think it's a good thing to simply go through them, so you can get a feel for how it works. So for V-types, there are several. So for this V-type release, this is the main table of this database. If you look at these lines, there are actually two types of lines. The lines with the columns are directives, and we'll get to those in a minute. The other lines, so these lines are field definitions. So they are the columns of your table. And so fields can have names, and they have a type. So this field is called, the name of this field is name, and its type is text. So at this point, it's probably a good idea to give you to talk about the types that our data modeling tools support. As I said earlier, and as you've seen on the web page, SQLite has several fields, like text fields, integer fields, reals, blobs, and basically that's it. So for our purposes, this was a little too slim. So we've added a few. We've added references, we've added enums, booleans is in there, and stamps. I think stamps are officially called date time. Yeah, I think so. And am I forgetting something? No, I think not. These are the main ones. And obviously, if you're using datetimes, these are remapped to text. For booleans are remapped to integers, enums are remapped to integers, and the same holds true for references. But it's not just a remapping that goes on. It's it's the information that's being stored as well. So our data modeling tools not only help you create a database, but they also allow you to, but they provide some introspection. So if you have a Flow application running on top of a database that's modeled using these tools, then you can actually figure out in the applications how particular types are constructed and what sort of data type particular fields are, and this helps your application to automatically render date times, for instance, or resolve references, or represent a particular enum or a boolean. So back to the data model, to the field specification itself. What you see here is most fields simply start with a dash. So here it says there's a field called parent, and it's a reference to another release record, to release. There's a field called category, and it holds an enumeration. And here it holds an enumeration. There's just an underscore here. Obviously, it should specify the name of the enumeration. And what it says here is the enumeration is called release category. So the underscore is actually a shorthand notation for release category. Underneath the vtype release, you already see here the release category specification, so the enum. Any case, so this is just shorthand. The name field, the name text field, it starts with an exclamation mark, and that means that this field should never be null, so it should not be an empty field. So the published stamp field should also never be empty. Version is just a text field, and here, well, as you've probably already seen, there's a comment, so dash starts a comment that actually tells us a bit about the notation that we're using for the version field. Last but not least, here's a status enum, so the last field is an enum again, and here there's no shorthand, it just says, the values that go in here come from the object status enumeration. And if we scroll down, you can see its definition. So a vtype has a particular number of fields with particular data types, and there's other stuff here. So let's start here. Since tables can have indexes attached to them, and these indexes can be very important, our data modeling tools allow you to have index directives. So the columns basically start directives, and this here says, please put an index on the parent field, and please put another index on the published field. If you look down a bit, the vtype node, there's an index on two columns, kind and item, and well, you can put in as many fields as you like, or a SQLite allows you to. There's something I forgot to tell you about the field notation. So there's fields start with a dash or an exclamation mark. You can also have fields start with a star. Star means it's a unique field. So these are the three basic options: dash, exclamation mark, and star for a regular field, fields that should not be empty, and fields that should be unique. So this would have made sense here to have the names of releases be unique, but for some reason we didn't do that. We just said it shouldn't be empty. That's fine. And you can have a similar unique marker on an index. So, for for instance, here we could have said index star, and this would have meant create a unique index on this particular table, on this particular v-type. Yes, and that's about it for the field specification. So back to the directives. There's the index directives, and here there are label directives. A label for a v-type allows you to specify how a record of that v-type, particular v-type, can be represented. So what it and actually what's after the label is a sort of a mini template. So what it says here is if you need to represent a record of this release, you can use its name value. But I could also have said like something like this, release, and then this would have been a literal text, and this would have been resolved at runtime. Right, let's go down and see what's here. So the next section is actually a definition of the enumeration that's used here. So here it says releases can be a release is either a main release or a patch release. And for enumerations, what you need to know is that there can be as many options as you like, and any option of an enumeration has a value and a caption. So here there's just like regular values 1, 2, 3, 4, 5, but this doesn't have to be. We could have said 100 for the main value and 201 for the second value. And since the ordering of the items is significant, we could also have done it like this. Well, it doesn't look so nice like this, but again, the ordering is significant, and you can design the options for your item, the items of your enumeration, any way you like. Let's see if there's anything else worth mentioning. Yes, here, a more shorthand notation. Like for references, and for both references and enums, you need to specify something else. So a field is a reference to another v-type, can be a reference to another v-type, and for an enumeration you need to specify the name of the enumeration. So, and as underscore is shorthand for take the name of the component, take the name of the field, and just put an underscore beneath them. The hex symbol is shorthand for take the name of the field. So here, this is actually shorthand for release is a reference to release. But this allows you to type things faster and keep things consistent. So it's actually fairly nice. I think this is all we need to show here. Components, they come in different categories. If you've ever downloaded our stuff, then you recognize this. Here's another interesting thing worth pointing out. Here's, for instance, a nice, more complex label for events. But this is the bit that's worth pointing out. I mentioned earlier that nodes, we have releases, components belonging to releases, and we needed to have a mechanism to put descriptions on both of them. So you can't. So since nodes have to be attached to either components or releases, you can't simply say, node is a reference to release or node is a reference to component. The reference needs to be a bit dynamic, and this is the way that we've solved this. So it's actually these two fields that allows us to say, okay, this is a node for a particular type, and here it says, so for instance, here it says, oh, this node goes, links to a release, and this field is used to specify which particular release. And please note the dot here, because this here means please look into my kind field to figure out what the value here means. So this is an interesting notation that you may or may not know about, but it's actually fairly flexible and powerful. So try it out and see if it works for you. Right. So just having a quick look. I think I already pointed out the comments, a dash. If not, then now you know that how you can specify comments. And now you've seen how these definitions work, and here you've seen the list of particular field types that you can use. It's probably a good way to show you how you can build your database using this particular definition. So let's go here. Here's the definition from last year, so that's correct. You can use the model to DB tool to take a model and create your database with it. It doesn't actually have to be, the database can even exist. If it does not exist, it'll create a database and just create the tables that you specify. If it's an existing database, it'll drop the tables whose v-type you specify. So it'll override both tables and enumerations, but you can actually use Model 2DB to enhance existing databases, as long as you don't overwrite stuff. So as always, you can use most of the tools simply without arguments on the command line to see what they expect. So Model 2DB expects a model file name and the file name of a database. So I can do it like this. Let's create a demo database. And that's it. So since this is not very eventful, let's open it up and see what's there. So right now I've opened the database we've just created in SQLite Spy. That's a nice Windows tool, GUI, to look at your databases, to manipulate them. You can run queries, you can do inline editing. In the other video I've shown you where you can download it. It's a fairly nice tool. And if you look at the schema tree, you'll see that here's the component, there's event, node, and release, and I should expand the tree so you can see how things worked out. All the tables are empty, obviously. Model definitions define the structure of the database. They don't define the contents. But let's put this here. Have a look at the release database. Look it up here in the tree. So parent is a reference. You'll notice that it ends up being an integer table here. Category is an enum, ends up being integer column is what here. Name is the text, version is text, published was a stamp, but it ends up being a text column here. And here in the not null column, you can actually see it's being flagged. So the exclamation mark here result in not null columns. So just the way we'd like it to be. The indexes, we defined 2 indexes, and the indexes were defined here. So here's the index on parent, oops, and here's the index on published, and it's pretty much as easy as this. Now, if I collapse the schema tree, no, that's not what I want. You'll notice that there are 4 other tables in your database now, and these are the tables that actually store the data model, basically. These tables enable the introspection that I talked about earlier. So v-type, here's the list of v-types. You'll recognize them. Here are the label directives that I talked about earlier end up being here. And as you can see, there are actually many more columns, and there are directives for those as well. But the thing is, we don't actually use them so much anymore. And at some point, I'll probably remove them. The level one is actually a new one. I can say, the release table is a level 2 table or a level 200 table, and levels is something that we've added to v-types to help us make a distinction between various types of tables, various types of v-types. For instance, if you look at this particular database, the top 4 tables are application tables, and the bottom 4 tables are more like system tables. And once you start building applications, you'll find that next to system tables and application tables, you might even have other tables as well that are created more on demand. And at some point after that, you'll find that you sometimes need to be able to distinguish between them. It really depends on the type of application you're building, but we found that if for some type of applications that use a lot of introspection, it's actually, it might be convenient to make this distinction. And the level directive, it's just a number, can be used to make this distinction. In any case, the v-type tables hold the main v-types, and obviously the most important bit about v-types are the fields. So v-fields hold the various field data. So this is something that you'll now should be able to recognize. If you look at, for instance, v-type release, it's the v-type with ID 2. Then you can actually see from here parent, category, name, version, published, and status, that these fields all belong to the release v-types, and well, the other information ends up below. V-category, as I mentioned at the beginning, v-category was actually the original name of enum, enumeration. And enumerations have items, and these end up in the v-item table. And there you have it. The language field, that's a good one to talk about. So there is some, we added some multi-language support to Flow several years back, and when you define enumeration, you can actually specify the language that the enumeration belongs to. So in this particular data model, we see that the language is just English. If you look at the component category, it says flows, web resources, support, files, documentation, and here for object status it says created, active, etc. But you could actually do something like this, language, and say this is English. Then put another object status enum in here and say, oh, let's have the Dutch version of this enumeration in here. So we can do that, then like this, actief, niet actief, and so like this. If you do it like, if you'd specify it like it, obviously at this point you'd have to make sure that the values match. But as long as the values match, you can redefine the same enumeration for as many languages as you like. So this is the way to go about it. So use the language directive and just redefine it. And if you do so, you'll find that the language field is then stored here. Okay, so we've looked at a model definition. We've used this model definition to create an empty database, or a nearly empty database. Obviously, the system tables aren't empty. If we put this away and later on you're wondering, or perhaps you lost this particular definition. I should undo all this. There is a way to extract the model from a database. And as we've just used model to DB, you can actually use DB to model to retrieve your data model from an existing database. So let's see what happens if we do it like this. Here it is, and we can use, you can specify the file name, and it actually prints stuff like this. And you'll notice it's exactly as you'd expect things to be. Well, maybe I should open it up. Demo data model, and there it is. So model definitions, two tools, model to DB and DB to model to create your database or enhance your database, or you could even use it to redefine your enumerations, update your enumerations. DB to model to retrieve your data model. There's just one more tool I'd like to discuss in this particular session, and that's a tool to help you enter data into this database, and that's the vimport tool. Vimport is a tool that enables you to take a file holding objects, and read those objects and store them in tables, as long as the objects match the data model. It's probably a good thing if I first show you what sort of file vimport expects. So for instance, last year for the Flow 2017 release, we created our database using this particular model for releases, for components, for descriptions, etc. And at some point we wanted to enter data into the database. So this is the way that how we did it. Let's first skip this section here for a minute and look at this part here. What this file holds is actually a list of objects. So here it says, here's a release object with this particular name and this particular version, and there's nothing else. Here there's a component object of this particular category. Category was here an enumeration, which in the database, let's open it up, is an integer, but you'll see here that this is not an integer. This is actually a text, but runtime should be remapped to the value 1. And so you'll see here that there is a component with this of the category runtime with this particular file name and contents that should come from this particular location. Please remember that contents was a blob, file name was a text. And as I said earlier, a component should be linked to a release. So what's actually missing here is the release is F2017. Oops, 2017. Why F2017? F2017 is the name that we've attached to this particular object. So this object here is of type release and has an internal name, not a database field, but an internal name. A name for the scope of this file called F2017. And using, if in a component I say, oh, the release of this component is the F2017. What does that actually mean? A component, if you look at the definition again, has a release field, which is a reference to hack, and hack means release in this case. So here it says component has a field release that is a reference to a release. So if you now look at the object data file, then it says, hey, this object has a release property, and it says F2017, but this name belongs to this object. So this is a way, to define that this component object belongs to this release object. It's actually fairly straightforward once you get the idea. And in this case, because this should have been part of all these objects, we realize this is a bit of a drag, having like half a dozen objects all with the same release property. So we came up with a way to specify all the components after this directive have the same release field, and that's what this is all about. So if you look at this, here it says for component objects we have a default for the release field, and the default is F2017, which actually means that we don't need this, we don't need this, we don't need this and this, because if it's not specified, there is a default. And if we now go to the top of this data definition, data object file, you'll notice that there are defaults for all the object types that we have. So here it says if there are any releases, the categories by default are the main categories. The publish date is this date. The status of the object, or a release object, is active. The status for a component is object by default. So you can can actually say, oh, I have a component that is not active, but if you don't specify it, this is what it'll assume. And, well, this is essentially it. If you look at it again, you'll see, so there's one release object, there are several component objects, and obviously there are lots of node objects. And here it says this particular node should be linked to a release, this particular release. The title of the node is summary, and these are the contents. This is the contents of this particular node. Apparently there's another node attached to the same release. I'll just go down. Here is a node attached to a component, and this particular component, and so forth, and so forth. Well, this file holds a list of objects. So what we'd like to do now is to take these objects and store them into our file. So I think the file was actually located here. Yes, here it is. So what I can do now is say, okay, please take these definitions and store them in our data, in our demo database. And there we are. If we now look here, we'll find that some of the red minus sign actually changed into green plus signs, and that's an indication that the tables aren't that empty anymore. So if I double click on the release node here, we actually find the first release record here, and you'll see that the category that we have, let's go back to the top. So there's no category specified here, but fortunately we had a default category called main, and main corresponds with the one here. And the same for status. Status was defined as active. If we quickly switch to the data model, you'll see that active corresponds to value 2, so that's why it says 2 here. Same for components. So there are actually 6 components. They're all linked to the one release, the release that we've just imported. And there are several categories. Well, what I can do is, I just noticed that I actually have definitions of all the 3 patches that we released, and we can use this to rebuild the entire releases database as it's hosted on our server. So, well, I didn't actually time it, but this is all it took for me to create an empty database with the correct structure and import all the data necessary for the application into this database. And if we look here now, if I double click on release again, you'll find that yes, there are actually now 4 records of the main release and the 3 patch releases. Several components. If you look at the release column, you can see that, you know, these 3 link to the first patch, these 3 to the second patch, and just 1 file for the third patch. This is the expiration fix for asynchronous requests. And that's about it. Well, there's a couple of things I should probably mention. Oh, first let's undo some of the stuff that I've done here. You'll note here, so the contents fields of components are actually blobs, And because this is an object description, it makes sense to not include the actual data in the object description. So we have a mechanism that enables us to specify, please take this file and, you know, store it as a blob into a particular column. But the thing I wanted to say is this is actually a feature we've added after the Flow 2017 release, so it's not been released yet. There are actually two other helpers. So this is a helper function that you can use. So for instance, if so this publish date here is hardwired, but I could actually have said something like this now, and I think I could actually have said now minus 1 day plus 2 hours or something like that. You can actually have dynamic timestamps or dynamic timestamps with offsets, and this works exactly the same way as it does in the if you're actually scripting and working with timestamps. And the other directive is pass, like this pass, which actually allows you to hash passwords. So if you have hardwired passwords, which we don't recommend obviously, but if for some purpose you need to put a password, a pre-computed hashed passwords in your database, you can use the pass helper. Right. Did I forget anything? No, I don't think I did. Oh, this is it. So, to wrap things up, you've seen our way of using textual model definitions, database model definitions. You've seen model to DB, you've seen DB to model, and the V import tool, and the way it works with object descriptions. And well, I hope it's been useful. If you please try it out. If you have any questions, as always, post them on the mailing list. It's a good place for everyone to discuss things and see what's happening. Well, I think we can end it here. Thank you for watching. Bye bye.